11.2, mixed strategies. In a game with a saddle point, the player should play the row and column with the saddle point every time. These are pure strategies since they do the same thing every time. Okay? If there is no saddle point, the game is not strictly determined, meaning that players should mix up their strategy. Don't do the same thing every single time. Okay? Mix up their strategy. Number 1, express each strategy as either a row or a column vector. Okay, so we're going to talk about what they're going to do and how often they're going to do it. Part A says the row player plays row 1 20% of the time and row 2 80% of the time. Now, this is not difficult. Okay, it's a row player, so we're going to have a row vector, a row matrix. And there's 2 strategies here. And the first strategy, they're going to do it 20% of the time. And the second strategy, they're going to do 80% of the time. And that is it for the row player. Okay, that's it. Part B says the column player plays column 1 half the time, column 2 1/3 of the time, and column 3 the rest of the time. Okay, so notice it's a column player, so I'm going to have a column this time. And there are 3 choices. Column 1, they're going to play half the time. Column 2, they're going to play 1/3 of the time. And column 3 is going to be the rest of the time. Okay, so you have to figure out what the rest of the time means. Well, get a common denominator there. 1/2 is 3/6, and 1/3 is 2/6. So what does that leave for the rest of the time? It's got to be 1/6 for the rest of the time. Okay, so when they say the rest of the time, that's going to be 1/6 of the time. And that is it for the column player's strategy. Okay, so think about it. This is different than last lesson. Last lesson, we would have done the same thing every single time. This time, they're mixing it up. Okay. Part C says, in a game of rock, paper, scissors, Bart, the row player, plays rock every single time. Okay, so notice, you've got a row, and you can label it if you want, rock, paper, scissors, as your 3 strategies there. Okay, but if he plays rock every time, that means 100% of the time, right? Okay, there's a probability of 1 that he plays rock, and so I'm going to say 1, 0, 0 for that. Okay, that would be a pure strategy. That would be what we were talking about in last lesson 11.1. Plays rock every single time, and paper 0 and scissors 0. In a game of RPS, the column player plays each choice equally. Well, what does that mean? What does it mean, equally? 1/3, 1/3, 1/3, right? Okay. Don't be afraid of fractions. Sometimes fractions are easier than decimals. I'd rather put 1/3 than like 0.3 repeating or something like that. I suppose you could, though. All right. So that's kind of our strategies that we're talking about. And the hardest part of this lesson is going to be we have to find what their best strategy is, what their optimum strategy is. So we return to this flowchart, and I showed you this in 11.1. In 11.1, we ended up right here. Okay. But in this section, we can start and we can try to look at dominated strategies, but there's not going to be a saddle point, and so the game is not strictly determined. We're going to be looking at 2x2 payoff matrices, though. So 11.2 is going to be over here. All right, the bottom part of this flowchart we'll save for next section, 11.3. But for right now, there's not a saddle point, so the game is not strictly determined. And this will only work for 2x2 payoff matrices. If it's bigger than 2.2, we'll have to do something else. Okay, so we'll use matrix multiplication to find strategies and value. Okay, so what does that mean? Okay, here's kind of the main idea right here. Here's like how to do everything. These yellow boxes, this is how to do everything. And I know students get really confused by this, but this is basically it. All right, how to find optimum mixed strategies with a 2x2 payoff matrix. Again, it has to be 2x2. If it's not 2x2, we're going to have to do something else. Okay. So to find the row player's optimum strategy, we're going to multiply this row vector. Okay, now what is this? P1 minus P. People get confused by this, but understand that all that means is it's like this. Okay, if this was 0.2, then we know that this is 0.8. Okay, if this is 0.5, then this is 0.5. If this is 0.3, then this is 0.7. These two numbers have to add up to 1, right? That's all that's saying. Okay, so it's not trying to be difficult when it says P and 1 minus P. It's just if you know this number is 0.3, then 1 minus 0.3 is 0.7 over here. We can figure that out. Okay, so this is just trying to say this is going to be their optimum strategy. But at the beginning of the problem, it's going to be variables, and we don't know what it is. This will be whatever the payoff matrix is, and that'll be given to you in the problem. And so you're going to multiply. You're going to multiply the row strategy times the payoff matrix, and you're going to get this. Okay, it's going to be some algebraic expression and another algebraic expression. And what we're going to do is we're going to set expression 1 equal to expression 2 and solve. All right, it's not that hard. The hardest part is multiplying the matrices. You probably forgot how to multiply matrices. Okay, now the column player is basically the same thing, but notice it's backwards. Okay, if you remember back to when we learned about multiplying matrices, this will be a 2x2, and this is a 2x1. Remember how these two numbers had to match? Okay, when we find the column player, it has to be in that order, otherwise the multiplication is not going to work. Likewise, when this was a 1x2 and this is a 2x2, and these two numbers had to match, okay, we're going to end up getting a 1x2. Over here, we're going to end up getting a 2x1. All right, this is coming back. This is good review for something we did early in the semester, matrix multiplication. Final exams coming up. Okay, this will be good review of something from earlier. Okay, but again, we're going to do the same thing. We're going to set that first expression equal to the second expression and solve. Bless you. Now the value of the game, okay, for the value of the game, now, we've already got the numbers. We've figured out the P number. We figured out this P number. It's going to be different, okay? But we've got all of the numbers that we need, and now we've got to multiply those numbers, the row player strategy times the payoff matrix times the column player's strategy. Okay, so down here at the bottom, once we're finding the value of the game, we know all the numbers. We just have to multiply them out. Okay, so row strategy times payoff times column strategy, and that's it. Okay, so this right here, this slide, this is the main event. This is how you're going to do everything pretty much in this section.